There are two hard problems in computer science: caching validation, getting polyfilling right, and off by one. So hi, I'm Frederik, and as you can tell by now, I wasn't born to become a stand-up comedian. I too work for IdeaNode, and we have really taken on and embraced web components as of late. I myself actually is a web component fanatic and has been so since the original Polymer preview back in 2013. If anyone in the room been around for so long? At least one. Nice. But as it turns out, I'm also a polyfill fanatic. So I'll take you through a journey of the art of polyfilling. So maybe this is you. You care about using the latest language features. Maybe you use something like object.values or array.includes. But you also want to use the latest web technologies such as web components, as we were talking about today. And that's a good idea. It helps with the iteration speed on your products. You have a better development experience, and it's all for the betterness of your users. Polyfilling is what enables you to do this, and I'm sure most of you in this room have tried at least to work with polyfills before. I'm sure at least you're gonna try it at least once in your career. But there are many ways to go about it, and let's take one of the patterns, which is what you see here. Here we have an import for core.js, which fills the holes in the runtime support for JavaScript. And we also have an import for the official web components polyfill. So these are blocking import declarations that needs to be evaluated before the browser can then move on and run the rest of your app. However, with this pattern, you're treating every version of every browser as your lowest common denominator. So let's take Chrome as an example. According to StatCounter, it has a global market share of over 60%. And yet, and Chrome has supported both the custom elements v1 spec and the Shadowdom spec since 2016. In fact, according to Can Use, it's around 1.39% of the global usage of Chrome that doesn't support these specs. And still we are asking everyone to pass and evaluate those imports for web components polyfills. So can we improve on that? Well, sure, we can use import expressions instead. This is something we also hear as dynamic imports, where we apply a feature detection, and if we decide that the features aren't supported, then we load the polyfill. So it's definitely an improvement, I'd say, but it isn't exactly minimal, right? I talked about whether we would like to use object.values and object.includes, but at the end of the day, we're still loading the entire thing. So let's see if we can get more specific than that. So here we have the similar approach, except we load only the specific features we need. But this brings us into a whole new territory. Now, what if object.values depend on the existence of other implicit dependencies? Put it another way, let's say you want to use array.includes. Well, that might depend on the existence of object.defined property. Okay, so now you add an import for object.defined property if that isn't around. For that one, that depends on object.getOnProperty descriptor. So you add that one. But that one, that depends on the existence of string.split. Mind blown. It doesn't take that much effort to arrive at this example, right? Where you have this file with potentially a lot of imports. But let's say you return to this file in a month from now. Do you remember what's going on? How do you know why you decided to depend on the polyfill object-defined property? And how do you know the order in which to load them? It can be really difficult. And even though your node Marches folder was already the largest object in the universe, it has now quadrupled in size with all those polyfills you need to go out and find on your own. And it's your responsibility to find the right polyfills, right? Just searching for mutation observer or NPM that gives you 74 packages. How do you find out which polyfill to use? And also your build step takes way longer. And that's whether you use Webpack, Parcel, Rollup, or whatever you use. You'll always be stuck at 92% chunk asset optimization. So in short, it turns into a hot mess quickly. So can we do something completely different? Well, there's something called ponyfills, which is practically like polyfills, except instead of patching the global objects, you then offer the functionality via standalone modules that you can npm install and import. Which makes sense. Actually, it's also better for performance because browser engines, there's been a lot of work going into optimizing them. But when you start patching globals, these engines like V8 and Chrome have to opt out of so-called fast paths. So it's a good idea. It's also particularly a good idea in environments where you don't have to worry that much about network speeds or bundle size. So it makes a lot of sense in Node.js and Electron apps. But I think that it's a horrible idea in browsers because you're back to the first example of treating every version of every browser as your lowest common denominator. The might use the native variant if it's supported by the browser. But you're still asking the browser to pass and evaluate the entire thing. So please don't treat every version of every browser as your lowest common denominator. That's my main takeaway. Unfortunately, that's exactly how most of popular front-end tooling does it. So Create React app for the React developers in the room is pretty familiar to you, I guess. And it doesn't bundle any polyfills by default, but it does encourage you to use the React app polyfill, which is basically just a way to put in some core.js polyfills for, depending on your configuration, IE 9 support or IE 11 support. And that makes me sad. And then the Angular CLI is pretty much an essential part of any Angular developer's toolkit. And in Angular, you have a polyfills file, and then it injects additional polyfills into your build, whether you like it or not, when you build your app. So you might say you want to support an ES5 environment, and you might say you want to support an ES 2015 environment. But no matter what you say, you'll still have polyfills applied to your bundle. And that makes me even more sad. Now Vue is a little bit different than the others, because Vue uses something called Babel preset environment, which is a really interesting development in modern front-end tooling. So are we happy? Well, let's find out. So Babel, I'm sure most of you know about it, or at least have heard about Babel, and I won't dive too much into what Babel is and what it does, but in short, it enables you to write your code using the latest language features and then transpile it into whatever environment you're going to target. And we don't have time to go more into that than this, but one of the latest developments to Babel's preset environment is that it can now automatically inject polyfills depending on your code. So in this example, I'm writing some weird code. I'm saying, does this array consisting of the strings foo and bar include foo? And then Babel will detect that I'm using array that includes and inject that import. So how do I feel about this? Well, I think it's a really good idea to see that we start thinking about, can we automate polyfilling? Can we take the responsibility away from us as developers, because it can be a real pain. Also, this approach makes it I guess I should probably attach it to power. Okay, so we're back.
Polyfill.
So anyway, it's not perfect, right? It doesn't care about, we spoke about web components before, but it only cares about language features. So it's not going to help you with applying polyfills for web components, for example. It's also pretty simple in the detections it can do, but sometimes it's also too good. Like, consider this example. We're console logging this thing if a radar prototype includes is not null. We're not calling includes, we're just checking if it is there, and still Babel will include that as a polyfill. So I wouldn't say that's what you want. Yeah, so that's what those three very popular modern front-end frameworks does. But so what? I mean, is this a talk about over-engineering your polyfills? Yeah, I guess it is. but none of those patterns are good for our users. So we already ship way too much JavaScript to them. Adi Osmani is an engineer at Google, and he wrote an article called "The Cost of JavaScript in 2018." And in that article, he finds that the median web page ships around 350 kilobytes of minified compressed JavaScript, which is roughly around 1 megabyte uncompressed that the browser needs to process. And while it's true that on desktop computers and high-end phones, you typically don't really feel this cost, well, try it out on a medium to low-end mobile and you'll quickly see the difference, where in this case it's up to 32 seconds slower. So doing this right not only translates into a better user experience, but it also improves your Lighthouse score. And that improves your SEO ranking. Leads you to more organic traffic, more conversions, and more money in the bank. All right, so hopefully by now I've got my point across that it's pretty hard to do polyfilling, right? It's an ongoing maintenance nightmare. It's an increase to your build time and longer time to market. And there's so many polyfills out there competing for your attention, and it's your responsibility to find out which ones work best, which ones interoperate the best. So how do we solve this? What do we actually need? I think that we need something that is easy to use, that supports all the APIs and the tech that you are using. We need something that only applies polyfills if the browser visiting your app doesn't already support those features. It shouldn't put additional load on your build, and it should help you automate as much of this as possible, especially as your app grows. Features gonna change. So I'm introducing a product called Polyfiller. Polyfiller is what I believe to be the next generation of polyfill. It's a completely free web service that sends back just the polyfills the users need. At its core, it's a web service, as I said. When a user visits your index.html file, you send a request to polyfill.app, polyfill.dev, saying, hey, this is the feature I want. And then Polyfiller will check, okay, does this browser actually support those features already? And send back what is missing. It supports a wide range of modern technologies, such as web components, the latest Intel specs, web animations, I guess you name it. And it automatically deduplicates and adds missing dependencies. And it takes care of the topological sorting of them. Beyond that, it supports self-hosting. It's completely open source. So if you don't want to talk with an external server, you can just host it on your domain. So let's see how it works in the browser. Because by the way, it also works in web workers. It also works in Node. So let's say that you have an index.html file and you request support for web components. Polyfiller will receive the request and pass the user agent information into a browser name, browser version, OS name, and OS version. It then looks up the web component's name, but that's just an alias for a multitude of features. Like some of the JavaScript features we spoke about, also something like web APIs, node prototype contains, custom element registry, and so on. It takes care of, because node prototype contains may also depend on other implicit dependencies that we spoke about. It will take care of all that stuff. The next thing Polyfill does is loop through each of those features and then check if it's supported in that particular combination of browser version, and OS. So Polyfill has partnered with BrowserStack, and I guess I think it's pretty amazing. But what we do is that we deploy those feature detections to hundreds and hundreds of browsers. So that's the usual suspects: IE, Edge, Chrome, Safari, Firefox, Opera on desktop, but also on Android. We support, I mean, the UC and QQ browsers, which are very important on the Chinese markets, Yandex, which are very important in Russia, of course also Opera Mini, Opera Mobile, and all the others. And also on iOS, and we test on real iPhone devices and real Android devices. So rest assured, the compatibility data is absolutely correct. So, when we've taken a look up and we've figured out if all of these features are supported, we take all those that isn't, and that amounts to a unique combination of features. And it just so happens that within the memory cache, there already exists a bundle just ready to be sent back to you, representing just those 4 missing features. And it will be sent back in a gzip, a broadly encoded version, if the browser supports it, and it will have immutable cache headers on it. So rest assured, performance is still pretty awesome. So I'd like to show you a comparison of using Polyfiller, and then on the one hand, and then using a more traditional approach of importing, let's say, core.js on the other hand. So in this test, we're running on a low-end mobile device on a slow 3G connection. And you see that the version of the app using Polyfiller is interactive is more than twice as fast as the example on the right with core.js. You have to look hard to get as much lighthouse points so easy, say. And in this next video, that was with caching disabled, but here's a video with caching enabled. Here we are interactive in 11 milliseconds when we use Polyfiller. And that's because that the device may be a low-end mobile device and the connection may be a slow 3G connection. But this particular device already supported all the features that we asked about. So the bundle is empty. And we already have it in the cache. And it also already had the cached version of the core.js version, but it still needed to pass the entire file, and it still needed to evaluate it. So even though the device supported everything, it still took at least 2 completely unnecessary seconds before it was interactive. So that's Polyfiller, and I promise in the title of this talk to show you how you could bring support for web components in 1 line of code. So I guess this is it. At this line of code, you index HTML file, and you have support for web components. So anyway, let's revisit this list. We need something that is easy to use, and I think Polyfiller is quite easy to use. We need something that supports all the APIs and tech that you are using. I think it supports all the modern APIs I use, and I tried my best to get it to work with the technology that everyone around me uses. But please say it loud if you don't think it supports the tech you're using. I'll make sure it does. I think we could tick all of the boxes actually, but there's this last one, automation. So it's a web service, and you are still responsible of asking for what you want to have supported. But couldn't we find a way to automate it? Well, I've been building an extension on top of Polyfill called Analyzer, which is kind of like Babel's preset environment we spoke about earlier. It can analyze your code, figure out how you use your code, and then generate the string you need to send along with your request to Polyfill. And you can integrate it with your build setup, so you don't even have to think about it. You can just put it in and never think about polyfills again. It also generates useful statistics on how often and in which files you use those features. Yeah, we said everything else. So basically, I think it's going to be a nice companion to your build setup. And when you take those things together, I think we've solved the challenge of polyfilling. So yeah, that's it. Any questions?